From a point R, two tangent lines are drawn to a circle of radius 1. These tangents meet the circle at the points P and Q. At the midpoint of the circular arc PQ, a third tangent line is drawn, meeting the other two tangents at T and U as shown. I express the area of the triangle RTU as a function of theta. So we're finding the area of this red triangle right here as this angle changes. First thing we want to know is that cosine theta, and we aren't using this one because this is 2 theta, we cut it into half, and you get a new point called C, and so we'll look at this one a little bit. Cosine theta is equal to 1, or I'll start with AP, which is here, angle's here, and the hypotenuse is here, RA. And then AR is equal to 1 minus 1 plus RC, and then RC is equal to AR minus 1. There we go, AR minus 1. And then from that we should be able to see that our AR is equal to CR plus 1, which we have here, and so that means CR is equal to 1 over cosine theta minus 1, because the AR, if we look at that, that's just, we can represent that as this right here, because this is 1 and this is AR, so that would be 1 over cosine theta minus 1. Now what we do is we take that and we wanted to find tangent now. So tangent theta is equal to TC over AR, or CR, excuse me. So TC over CR is what we have. So we can plug in for CR because we already have it. We don't have TC. Okay, no problem. That's what we're solving for. So TC is equal to tangent theta. But for CR, we want to get a common denominator, so we're going to have 1 minus, let me slide this over. There we go. 1 minus, my bad, my apologies. So TC over 1 minus cosine theta over cosine theta. So we multiply 1 minus cosine theta over, and that means we have, that's going to give us TC is equal to tan theta minus tan theta cosine theta. And we want to put that over, for TC we still have a cosine theta over here. Alright, let me erase some of the board and then I'll finish the algebra there. Okay. Let me erase this too. Okay. That means TC is equal to Okay. Okay, next, what we want to do is we want to find the area of a triangle, which we know as 1/2 times base times height. Because we end up doubling up later on, we can multiply by 2 because we're only doing half a triangle right here. And we're trying to find RTU, so we can multiply by 2. And we just have base times height. And if we look at this, the base would be TC. So we have TC multiplied with TC is multiplied by the height RC. Okay. This one's going to take a little bit of room to work out, but it's the last step we have. That means we have tangent theta minus tangent theta cosine theta over cosine theta. And this is the area. I'm gonna go ahead and get rid of this triangle since or this diagram since we don't really need it anymore. Alright, and then this is multiplied by 1 minus cosine theta times 1 minus cosine theta. I'm going to continue the work for this problem under here. I'll just move this up since some of you guys may be looking at it. By the way, your guys' test is going to be moved forward a little bit since we covered more material than I thought. So area is equal to tangent theta minus tangent theta cosine theta. So instead of rewriting that whole thing, I'm just going to take this and copy it over. And then, well, let me make sure I leave that here. And then we're going to have that same thing, but we're just going to have a cosine theta distributed to each term. So we have, this is going to be, none of these change sign, but then you have minus cosine, and then multiply by cosine here. This will change sign, and you have a squared, cosine squared theta. And let me get rid of, oh no, it is over that. Okay. Let me draw a straight line from here through here, and this is all over cosine theta. So if we look now, we can see that cosine theta and tangent theta right here are going to become, let me see, we can factor out a tangent because these all have tangent. So we have A is equal to, let me clear some board room right here. I'll finish that here. Factor out the tangent term. And then that's going to be, we factor out tangent, we have -2 cosine theta. I'm going to write cosine squared theta because I just realized this is quadratic. -2 cosine theta. And let me scoot over a little bit this way. Plus 1. There we go. Over cosine theta. So area is equal to, area is a function of theta, maybe we'll call it that, is equal to, changes sine over cosine, so this is basically going to be sine over cosine squared theta. And then inside here, it's going to be the same thing. If I give you this on a test, your answer can stop right here. You don't have to go any further. Double up and that 2 goes away. Yeah. So area is equal to, I'm going to write the final answer down here instead of right here because I was running out of room. So you have tangent theta is equal to minus 2 sine theta plus sine theta cosine theta all over cosine squared theta. Alright, that is the solution to this problem. Let me see what else. Yeah, that's all I have for you guys today. Don't forget about the test. Remember the formulas we talked about, and have a good day. All right, peace out.